Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 9 to 12, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 9. Rochelle is training for a marathon. For each of the last 5 weeks, she has recorded how many miles she has run. Rochelle runs a whole number of miles each week. Her median is 23 miles, her mode is 29 miles, and her range is 8 miles. How many miles in total has Rochelle run in the last 5 weeks? You may use the boxes below to help you. And then we're going to put the total number of miles that Rochelle's run at the bottom here. So we're working with averages. So all of them need to be whole numbers, so we're not going to have any decimals. The median is 23 miles, so that's the middle number. So we have 1, 2, 3, 4, 5 weeks, an odd number of weeks, so 23 has got to be in the middle there as the median. Okay, the mode. Okay, the mode is the most common. So we need 29 to appear the most often here, but I'm going to write these in order, so it's going to have to be on this side. So I'm going to put 29 in here twice, because currently it's the mode. Because it appears twice, 23 only appears once. So as long as we put 2 different numbers in here, our mode will be 29. The range is 8 miles, so that's the biggest, take away the smallest. Okay, so the biggest, 29, take away the smallest, gives us 8 miles. So we're going to do 29 take away 8, which is 21. So our smallest value must be 21. Now, we don't want to have the same here. We don't want to have 21 or 23 because we need 29 to be the mode, the one that appears the most often. So it makes sense here that we've got 21, 23, whole number miles. Let's put 22 in the middle. Okay, so our middle value, our median is 23. Our mode, our most common, is 29. And our range is 8 miles from 21 to 29, smallest to the biggest. So we want the total number of miles, so we're going to do 21 plus 22 plus 23 plus 29 plus 29. So that's 124 miles in total. Question 10. 2 different companies use pie charts to show the proportion of male and female employees. So we've got company A and company B, male employees, female employees, male employees, female employees. Part A, Jamie says company A has more female employees than company B. Give a reason why he may be incorrect. So the reason that he may be incorrect is we actually don't know how many people work for each company. So yes, the males for company A take up 108 degrees of the pie chart, but in company B they take up more of the pie chart. But company A could have a lot more employees than B does. So we can't compare these angles directly. So my explanation of why he may be incorrect is that we don't know how many employees there are in each company. Okay. Part B, calculate the difference between the percentage of male employees in company A and the percentage of male employees in company B. So we want the percentage of male employees in each company, and then we want the difference between them. Now, currently we're working with angles, we're working with degrees, that's not percentages, so we're going to have to convert to percentages. So a full circle is 360 degrees. So in company A, 108 degrees are male employees. So 108 out of the 360 degrees in that full circle are male. So if we put that in our calculator and multiply by 100, it will give us our percentage of males in company A. Remembering to use our fraction button, remembering to arrow off, guys, okay? So that's 30% of employees in company A are male. We're going to do the same for company B. So this time it's 234 degrees out of 360 multiplied by 100. So that's 65%. Remember, we want the difference between the percentages. So we're going to do 65% subtract 35. Which is a 30% difference. Question 11. A shop sells the same breakfast cereal in 2 different size boxes. So we have a 500 gram box and a 900 gram box. Which box is better value for money? So we've got to select one of these, but we must show our working out. So we're going to do the working out before we then decide which one is better value. So what we need to do here is find out how much the smaller box costs for an amount that we can compare directly to the bigger box. So they're both 500 and 900 grams, so they're working in the hundreds. So let's put the small box here, and I'm going to use myself a little proportion table. We know how I like those. And then I'm going to put the big box here, and again, its own proportion table. So this is grams, this is how much it costs. So for the smaller box, for 500 grams, it costs £2.21. And then for the bigger box, for 900 grams, it costs 3.78. Now what I want is to find out the cost for an amount that I can compare directly. Now 500 and 900, they're both multiples of 100. So I'm going to work out how much each box costs for 100 grams, and then I can compare them directly because the measurement is the same. So I'm scaling down here from 500 to 100. I would divide by 5. So I'm going to do the same here for the money. So £2.21 divided by 5 is 0.442. We're dealing with money. Normally I'd do 2 decimal places, but I'm going to keep all of those decimal places just in case I need that last one to compare my values. I'm going to do the same on this side. I'm going to make this 100 grams. So we're scaling down. We're going to divide by 9 this time. So I'm going to divide by 9 on the other side. So 0.42. I didn't need that 3rd decimal place, but sometimes another number appears, and if they matched it here, I'd need that 3rd value to compare. Anyway, we can say that for 100 grams, the small box is 44 pence, and for 100 grams, the bigger box is 42 pence. We want better value for money, so we want that cheaper value here, so the bigger box is better value. (12a). Simplify 10a divided by 2. So it's 10a divided by 2. 10 divided by 2 is 5, and then we've got the a left, so our answer is 5a. Part B. Solve 4x subtract 5 equals 2. We know I like to write this out, so I've got a little bit more space. So I'm aiming to solve for the variable, which is x. So I'm aiming to isolate x. So the first thing I'm going to do is I'm going to eliminate this minus 5 here. So to eliminate that minus 5, I need to do the inverse, which is add 5. So when I add 5 to the left-hand side, I get 4x. I have to do the same to the right-hand side to balance the equation. So 2 plus 5 gives me 7. Now I've got 4 times x. I want it to be x equals. I want x on its own. So the inverse of multiplying by 4 is to divide by 4. So 4x divided by 4 gives me x. I need to do the same on the other side. So 7 divided by 4, I can't do in my head. I'm going to write that as a fraction, and I can leave that there because they've not told me what form they want my answer in. So I'm going to leave it like that. Part C, expand. 7 multiplied by G subtract 6. Okay, a couple of different ways you can do this, but you just need to make sure that what's on the outside gets multiplied by everything on the inside. So the first thing I'm going to do is 7 times G, which I write as 7G. And then I'm going to do 7 times negative 6. Remember, you have a calculator. If you're not great with negative numbers, put it in your calculator. So that is negative 42. So I write negative 42 next to my 7G. Part D. Factorise. 6x, add 4. So factorising is the opposite of expanding. We're aiming to pull out the highest common factor of all of the terms in this expression, and then what's left goes inside a bracket. So we're bringing a bracket back in. So we've got the terms 6x and positive 4. So we're going to find the highest common factor of 6 and 4. Okay, so factors of 6 are 1 and 6, 2 and 3. Factors of 4 are 1 and 4, and then 2. So the highest common factor is 2. So we're going to put 2 on the outside. 6x divided by 2 is 3x. 4 divided by 2 is plus 2. Notice that the x is inside the brackets because there isn't an x in both terms. So it has to stay where it was. Part E. The shape below is a square. Not drawn to scale, but we can see that this square has a side length of 8x. Find an expression for the perimeter of the square and simplify your answer. So the perimeter is all the way around the outside of the shape. This is a square, so we know that all 4 sides are exactly the same. So we would add these 4 sides together. So I'm simply going to do 8x multiplied by 4 because I have 4 sides that are the same. 8 multiplied by 4 is 32, and then we've got that x, so it's 32x. Part 2. Find an expression for the area of the square and simplify your answer. So the area is the space inside the shape, and for the area of a square we multiply the sides together, so length and width technically for a rectangle, but because they're the same on a square, we're going to do 8x multiplied by 8x. 8 multiplied by 8 is 64. X multiplied by x is x squared.